Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the Spot On Weather 2021-22 Winter Forecast Part 2. And on tonight's video, I throw in a funny video of Chevy Chase here before Clark goes down that hill, that snow hill, when he was doing the sledding with this metal disc, which is really, really interesting. Of course, it was a funny part of the movie and everything. So I just have to, I guess I got the winter theme going here, each of these introduction videos here. So here's a great memory if you like the movie Christmas Vacation for sure. All right, so for part 2 of the winter forecast video, I have decided based on further research I've done over the past week that I'm going to divide up the winter forecast into 3 parts. Initially, my plan was to do 2 parts, but there's just so much good information, a lot of research that I've been doing into developing this forecast. This is not an easy forecast by any stretch, as there's many, many variables in the northern hemisphere, teleconnections, and the overall global circulation, the upper air pattern, that really determine what type of weather we will see for the winter season. So I've been doing my research and I've added some additional slides even onto my previous first version of this forecast. So I'm going to divide this up into 3 parts now. This is part 2, and for part 2 I'll be focused on teleconnections discussion. Mainly we're talking about the MJO, the QBO, PDO, EPO, and AO. And then part 3, I'll wrap it up, the teleconnections discussion, with NAO, PNA. I'll delve into the stratospheric polar vortex discussion, sea surface temperature anomalies, and solar activity discussion. And finally, video 3, I'll have the actual weighted forecast factors that I'm using this year, as well as final thoughts and the forecast weather maps. Again, as a reminder, this winter forecast covers the period for meteorological winter from 1 December to 28 February. All right, before I get into the Madden Julian Oscillation, I found a couple other very useful research on La Nina winter weather patterns, and I really wanted to delve into this a little bit more. So overall, with a La Nina pattern, we typically see that purple line there. The purple solid line represents the polar front jet stream. So La Nina tends to favor an upper level ridge, a long wave ridge in the Gulf of Alaska, and then a downstream trough from western Canada into the northern plains across the Midwest and New England. In general, that peach colored arrow, that represents your Pacific jet. The Pacific jet there, generally heading towards the Pacific Northwest, and that's really why the Pacific Northwest during La Nina winters typically has above normal precipitation. Now, that's usual. We usually have a storm track that's variable during La Nina winters, and we also have periods with a stronger polar jet stream there, again denoted by the purple line, that purple arrow. And we also see more in the way of Arctic outbreaks during La Nina winters as well. And the other main point that I wanted to mention, and we'll get more into sudden stratospheric warmings, those events once we get to the stratospheric polar vortex in video 3, but during La Nina, we typically see more of the sudden stratus forming events and a weakened polar vortex. And that occurs on the average of 60 to 75% of the time during La Nina winters. So that was some research that I conducted, and it's really good information to put out. Now, when we talk about the differences between an El Nino and a La Nina, I mentioned in the video 1 for the winter forecast about, we have a La Nina forecast for this winter. The strength of that La Nina is very, very important as far as whether it's a weak, a moderate, or a strong La Nina. I wanted to show you the importance, again, of where the tropical rainfall is occurring across the equatorial Pacific. And this really makes a big difference. For example, on the left there is a strong El Nino. Generally have a much stronger jet stream across the Pacific Ocean during El Ninos. And you'll notice that you typically have wetter conditions during the strong El Niños in the eastern and central equatorial Pacific. And you have drier or sinking air motion out towards the Philippines, out further in the western Pacific Ocean. So during strong El Niños, we have tropical convection, rising air motion, thunderstorms, and rainfall, and the jet stream extending across central and eastern Pacific. And this typically, a strong El Nino typically triggers a positive Pacific North American pattern, a PNA pattern. Now, strong La Nina on the right, we have opposite things going on, right? So we have drier than normal conditions during strong La Ninas in that eastern and central equatorial Pacific. We have a weaker jet stream. Notice that red arrow there is shorter in magnitude. And then we also have a wetter period of weather over the tropical rainfalls over Indonesia. All right, and the strong La Nina generally tends to trigger a negative PNA pattern. These graphics here are courtesy of NOAA, so I just wanted to show you that. Now we're going to get into a discussion on the Madden Julian Oscillation, otherwise known as the MJO. And if you look at the forecast there of the MJO on the left, this is a forecast that was issued fairly recent here in late September of 2021. All those lines generally represent various forecast models, and they generally go out through the end of October. You'll notice the center circle of the MJO phase diagram. If the line is within that center smallest circle of the MJO diagram, that generally indicates that the MJO is in a null phase, very minimal impact for the United States weather when it goes in that smaller inner circle at the center of the diagram. Keep in mind, too, that the MJO is divided into phases 1 through 8, and you can see how those phases are sectored. For example, if the MJO is in phases 8 or 1, we typically see strongest convection over the Western Hemisphere and Africa. If we see phases 2 and 3 for the MJO, then the strongest convection is located over the Indian Ocean. If we are in a phase 4 and 5, that would be the maritime continent would see the strongest convection. That's closer to Australia. And then phases 6 and 7, we'd have the strongest convection in the Western Pacific. If you look at the composite, the temperature composite for December, January, and February, I wanted to show you again the different phases of the MJO and the type of temperature anomalies you get with each phase for the winter months, the meteorological winter months. Note, phases 8 through 2 are associated with colder U.S. temps, eastern U.S. temps. That's 8, 1, and 2, those phases. Generally, the mildest phases are 4 through 6, and even 7 is fairly mild for the months of December, January, and February. The orange shading generally indicates on the diagram on the right above normal temperatures, and then the blue shading colder than normal temperatures. So you can see the importance of the Madden Julian Oscillation and where that strongest tropical convection is occurring, where the enhanced convection and suppressed motion is occurring, those phases. All right, this is a great diagram. I show this in a lot of my videos. Madden Julian Oscillation phases 1 through 8. In general, this generally tells you where the strongest upward vertical motion is occurring in the tropical equatorial Pacific. Generally, again, 1 would indicate the strongest convection occurring around Madagascar, closer to the Western Africa continent. 2 and 3, generally the Indian Ocean. 4 and 5 would be the maritime continent. And then 6, 7, and 8. 8 would be closest to the date line there, the international date line at 180 degrees west longitude. So again, just showing you whatever the phase is for the MJO, this corresponds to where the strongest convection is going to be at that particular time. And that plays a huge role in our sensible weather in the United States for the winter season. Another great graphic here, MJO Phases and Weather. See that solid black line? If we divide that 8-phase diagram in half, phases 4, 5, 6, and 7 generally yield warmer winter temperatures. Phases 8, 1, 2, and 3 Winter and spring have colder temperatures. All right. The 2020-21 winter season, that was mainly influenced by a null amplitude MJO, resulting in minimal weather impacts for the United States for the winter season. I'll show you examples of what it looked like here in a moment. The negative North Atlantic Oscillation, that negative NAO, and the weakening polar vortex were definitely more dominant climate drivers this past winter. Here's what the phase diagrams look like. I took a few different samples from the past winter season, the 2020-21 winter season. You'll notice that solid green line, that bright green line. Generally, the graphic on the left is showing you a December 20th, 2020 plot of the MJO phase diagram, and the graphic on the right is the MJO phase diagram for 17 January, about a month later. Green line right within that inner smaller circle indicating the null phases of the MJO. And this occurred for the majority of the 2020-21 winter season. Moving on now to the phase diagram on the left for MJO for February 14th, 2021. So now we're progressing into February. And then the graphic on the right shows the MJO phase diagram for February 28th at the end of February in 2021. You're starting to see in mid-February, the MJO started to become a little bit more active toward the end of the winter season. In general, the further away you get from the inner circle there, that null phase, the further away you get from the inner circle, the greater the magnitude of the MJO. So the greater the impact, basically, to our sensible weather in the U.S. So overall, last winter season, MJO in a null phase for the good majority. For the heart of winter anyway, December and January. And then by mid to late February, the MJO started coming out of its slumber, so to speak, and actually moving into phases 7, and then on the graphic on the right, really fairly weak in magnitude, but going to phase 8 by the end of February. Another thing I like to talk about is what's known as a Quasi-Biennial Oscillation. I abbreviate this QBO. And in general, there's a big difference. Basically, QBO is the zonal winds in the equatorial stratosphere. Now, the stratosphere is that second layer of the atmosphere. So high above the equatorial areas in the stratosphere, you have these zonal winds, which blow either from the west or the east. In general, the graphic on the left shows the GFS analysis earlier in the month of September 2021. That blue shading on that graphic on the left indicates negative values, negative magnitudes, and then the orange shading indicates positive magnitudes. All right. So if you see the blue shading, that generally equates to negative values, and a negative QBO equates to easterly winds blowing in the stratosphere above the equatorial areas. Now, with the easterly QBO forecast this winter, we're expecting to be an easterly QBO winter. This typically leads to colder than normal temperatures in the eastern United States. Again, negative values generally equate to an easterly wind or easterly phase of the QBO, and the positive values equate to the westerly phase of the QBO. The graphic on the right shows the tropical stratosphere, the zonal winds in meters per second. Generally, you'll notice this graphic on the right, the reanalysis of the QBO. It goes back to April 18th of 2003, all the way up to July 1st of 2020. You'll notice the general cyclical nature to the reversal of winds from easterly phase QBO to the westerly phase QBO. And so yellows and oranges on the graph on the right represent that westerly winds above the equatorial stratosphere, and the blue shading indicates the easterly phase of the QBO, those negative values, easterly winds. So in general, you notice, blue equals easterly QBO, yellow indicates westerly QBO, and this is very important when you factor into the sensible weather in more ways than one, and I'll get into those as we delve. If not in this video, in video part 2, I'll get into it in part 3. If we look at the history of the QBO going back to just before 1980 up until the present time, the blue colors indicate the negative values associated with the easterly zonal winds, the easterly QBO, and the red spikes indicate positive values, which equate to the westerly QBO. So again, very cyclical in nature. You see, you have a positive phased or positive value westerly QBO with the red markings, and the negative easterly phase is blue. And so they alternate from positive and negative, positive and negative. Westerly winds in the equatorial stratosphere to easterly winds. So very important to take a look at this particular property. If we look at the general, that graphic on the left shows a December to February time period from 1980 to 2021. These were surface air temperature anomalies correlated with an easterly QBO on the left. And you'll notice the blue shading, it generally equates to below normal temperatures. And so it was colder than normal across New England, down through the eastern U.S., down even to the Gulf Coast with the easterly phase QBO, and milder out over the western U.S., off the west coast into western Canada with the easterly phase QBO. If you look at the right-hand diagram, that shows also the December to January time period, 1980 to 2021. This is the 10 millibar geopotential height. And you'll notice the yellow and orange coloring there on the graphic on the right. That generally indicates higher pressure. We have higher heights or higher pressure up over the North Pole area, up in the Arctic. And that usually equates to, you get that kind of setup at 10 millibars. That generally equates to a weakening stratospheric polar vortex. So easterly QBO leads to a couple things. It leads to a weaker jet stream. And that weaker jet stream then has the ability to become more meridional, where you have a lot more wave-like motions or perturbations in the upper air pattern. And also, easterly QBO equates to more sudden stratospheric warming events, where the stratosphere warms dramatically over the polar areas, and this weakens the polar vortex. Westerly QBO, on the other hand, when you get the westerly zonal winds over the equatorial stratosphere, you get reduced chances of sudden stratospheric warmings and a stronger polar vortex. So again, this is where it kind of ties in with what we look at in developing the winter forecast. Got to take a look at it. So we're looking at an easterly QBO this winter, so we have to keep that in mind. It's one of the factors we're using in our winter forecast. Okay. Now, let's take a look at the Pacific Decadal Oscillation. This is known as a PDO. In general, on the left, I'm showing the, going back to the year 2000, how we go from a negative phase to a positive phase PDO. And if you notice, the majority of the period since the year 2000, so going back about 21 years, we see more blue coloring on that graphic on the left, which is indicative of a negative PDO. Now, a negative PDO, if you look at the negative phase PDO on the right-hand side, generally your coolest water temperatures are occurring immediately along the U.S. West Coast in a negative QBO, or negative PDO rather. So we have the coldest water temperatures right off the west coast of U.S., and we have much warmer temperatures over the North Pacific to the west of the United States. Okay, so a negative PDO, cool water temps over the eastern Pacific, this generally favors upper-level troughing into the western U.S. and a milder eastern U.S. Okay, a positive PDO, on the other hand, which if you look at the graphic on the left again, those red spikes and the positive values, those indicate your positive phase PDOs. Not a whole lot of that. We have had a pretty good amount of positive PDO winners there from the year 2014 to the year 2017, it looks like. But that positive PDO is going to result in the warmest water temperatures over the eastern Pacific right off the U.S. coast. And that generally favors ridging into the western U.S. and a colder eastern U.S. Okay, so just something to keep in mind with, we talk about Pacific Decadal Oscillation, the PDO. If we look at another teleconnection known as the Eastern Pacific Oscillation, or EPO, in general, with a positive EPO pattern, we generally have a much faster Pacific jet stream. It features faster zonal flow, faster movement of the jet stream from west to east, which floods the lower 48, the U.S., with milder Pacific air if you have a positive EPO. In general, the coldest air remains up over Alaska with a positive EPO. Look at the mild temperatures associated with a positive EPO there. Wow, mild across the U.S. The yellow shading there with the word warm on the left-hand graphic. Now, in the negative EPO pattern on the right-hand side, this usually features a ridge over Alaska and a trough over eastern North America. That looks very similar to a La Nina jet stream pattern, doesn't it? In general, you get much colder temperatures across the northern plains into western Canada, and near normal conditions along the mid-Atlantic. Very mild in Alaska with a negative EPO pattern with that huge Alaskan ridge. A lot of warmth is moving northward towards the higher latitudes in that case. So a negative EPO favored this winter. It's quite interesting to look at the correlation, again, in the pattern associated with La Nina winter. You got this big ridge over the Gulf of Alaska with a negative EPO pattern. And you also have that big ridge, if you go back to the La Nina pattern, see that? The big ridge over the northeastern Pacific and New Alaska with La Nina pattern. So this could be an example if La Nina and the EPO, the negative EPO, if they come together this winter, that could have a constructive interference type effect where both of those teleconnections are working together. Something to keep an eye on for the winter. And then we look at the winter season, the last season Pacific North American pattern. Generally last winter, look at the graphic on the left by the blue bars there, those vertical bars. When they dip below the zero line, that's a negative PNA. Now, negative PNA is associated with a trough in the western U.S. and a ridge in the eastern U.S. So with a negative PNA, you get more of colder temperatures in the western U.S. and milder temperatures in the east. If you have a positive PNA, if you see some of those vertical bars there on that graphic on the left from last winter, for example, we had a predominantly positive PNA pattern from late November through much of December into mid-January last winter season. That's when you get a strong upper level ridge and warmer temperatures across the western U.S. and a downstream trough across the eastern U.S. The graphic on the right shows the strongly positive PNA in early December 2020, that graphic on the right, and shows you where the above average heights occur over western U.S. and Canada, and then the below average heights across the eastern U.S. by the purple shading. All right, so interesting, just wanted to show you that from last winter. Now when we talk about the Arctic Oscillation, AO, again, there's two phases to the AO. Just in review, there's a positive phase and a negative phase. Now, if you have a positive phase Arctic Oscillation, you generally have lower pressure at the higher latitudes over the Arctic, and you got higher pressure over the Atlantic Ocean down towards 30 degrees, 40 degrees north latitude. And you generally get more of a west to east jet stream, a more zonal jet stream with a positive phase AO, and you get the coldest air to remain well up over the northern U.S. all the way up into Canada and the Arctic. If you have a negative phase AO, however, you get a much deeper diving jet stream, polar front jet stream, which tends to transport much colder air to the Midwest and eastern U.S. in a negative AO phase. And you also notice the pressure patterns are reversed with a negative phase AO, where you're getting high pressure in the high latitudes over the Arctic and lower pressure at lower latitudes, or I should say mid-latitudes in this case. So a big difference in the transport mechanism, meridional flow with a negative phase AO. Much colder air is free to come down from the Arctic in Canada into the United States. The graphic on the right shows the various phases of negative and positive AO. The red positive values, the red spikes, that indicates a positive AO. Positive AOs are usually associated with milder winter seasons across the eastern U.S. The blue spikes generally indicate a negative AO, all right, and that is associated with colder than normal temperatures across the eastern U.S. Additionally, with the AO phase, the Arctic Oscillation phase, it is a surface reflection of the stratospheric polar vortex. So usually if you get a weakening polar vortex, that leads to a negative AO, while a stronger polar vortex leads to a positive AO. Just keep that in mind. If we look at the positive negative AO pressure distributions, the graphic on the left example of the negative phase AO, and that occurred during the winter of 2009 and 10. You'll notice the maroon shading coloring there. That generally indicates difference from average pressure, and it's on the order of 10 millibars above normal. So you got much higher pressure with a negative phase AO over the high latitudes into the Arctic, and you have lower pressure in the mid latitudes indicated by the purple shading. Now, there was a major polar vortex disruption during the winter of 2009-10, and that is predominantly the reason why you see the negative phase AO. The positive phase AO on the right, that occurred during the winter of 1988-89, where the purple shading represents lower pressure over the Arctic and higher pressure over the mid-latitudes. All right, so just the opposite pressure distribution. If we look at positive versus negative AO winter impacts, okay, with a positive AO, you typically get frequent warm-ups, warmer than normal temperatures, anywhere from the northern plains down into the Midwest to the eastern seaboard, mid-Atlantic. Also during positive AO phases, you tend to get fewer nor'easters. You also get more heavier rain events during positive AO phases along the Gulf Coast states. With a negative AO phase, you tend to get much colder air from the Midwest, but especially the mid-Atlantic and southeastern U.S., and he also tends to lead a negative AO to increased snowfall along the eastern U.S., mid-Atlantic. Negative AO tends to lead to more nor'easters, those coastal storms of winter along the East Coast, and more cold air outbreaks overall. So there's a big difference here between a positive versus a negative AO phase. If we look again at the sample case of the 2009-10 winter season and the strongly negative AO, again, look at the pressure distribution. Now, that globe there with the pressure distribution, that's early December 2009, where when the AO, the Arctic Oscillation, entered a strongly negative phase, that persisted through early January 2010. And then it redeveloped again in February, where we had Arctic air basically maintain higher pressure than the lower latitude air masses. And so frigid air was able to push down into the United States. And that is denoted by that purple shading there in the graphic here. The Arctic, on the other hand, was warmer than average due to the higher pressure distribution over the higher latitudes. And generally you had that warmer than average air over the Arctic, while most of the mid-latitude regions around the world were colder than average by the blue colors. So again, very important. Again, note the highest pressure over the Arctic region. And this has been talked about in many research papers. It's known as a warm Arctic cold continent. If the Arctic warms up exceptionally high levels, then the coldest air from the Arctic then tends to move southward towards the mid-latitudes in the northern hemisphere. Coldest air, again, filters southward into the U.S. during this negative AO winter season. Now let's take an opposite case here and talk about the positive, very strongly positive AO during the 2019-2020 winter season. And it's no surprise here, if you look at the graphic on the left, generally showing you the average sea level pressure during the month of February. This is just a sample of it. This was a leap year, so it went out to February 29th. Generally, the purple shading indicates lower than normal sea level pressure over the Arctic. And then we had the yellows and greens indicate higher pressure over the mid-latitudes. So lower pressure over the Arctic, higher latitudes, higher pressure over the mid-latitudes generally leads to a stronger positive AO or Arctic Oscillation, a stronger polar vortex in this case. And there's my summary in the bottom. You can kind of see the graphic on the right. The blue bar is strongly in the positive territory for that particular winter, 2019-20, especially January and February. I mean, look how high some of those values got on the positive side. all the way up to +6 on the AO. And Arctic air basically remained bottled up over the Arctic region all winter due to a strong stratospheric polar vortex. And the positive AO in general results in decreased energy transfer from the troposphere to the stratosphere, and that keeps that polar vortex strong. Now that is taken directly from research conducted by Dr. Judah Cohen. So I've definitely cited him here for that particular relationship from his research. If we look at the 2020-21 winter season AO, let's take a look at last winter season's Arctic Oscillation. You'll notice on the graphic on the left, those blue bars are in negative territory pretty much from the first few days of December all the way through mid-February. So last winter season, it was definitely influenced by a persistently negative Arctic Oscillation. That also coincided with a very strongly weakened polar vortex again. So you notice the relationship between the AO, which is that surface reflection of the stratospheric polar vortex. Okay. All right, that wraps up part 2 of the video. Stay tuned for part 3, when we will cover, again, in the final video of the winter forecast series here, I'm going to cover the North Atlantic Oscillation, NAO, the stratospheric polar vortex, Arctic sea ice, Siberian snow cover, sea surface temperature anomalies, the solar activity, and our official 2021-22 winter forecast for Spot On Weather. I certainly hope you enjoyed the video tonight. Again, what we covered were some very important concepts. We talk about climate drivers of the winter season and teleconnections, going from just rehash on the La Nina winter weather pattern, the type of jet stream that typically sets up, and where those storms generally tend to follow the jet stream axis. Talked about the importance of, the difference between El Nino and La Nina, and where the rising air motion occurs in the equatorial, eastern and central Pacific, whether we have rising or sinking air, wet or dry conditions, and that helps to trigger either a positive or a negative PNA pattern. If we look at the Madden Julian Oscillation, a very important driver in the tropical Pacific, and showing you the different phases of the temperature composites, which are associated with the milder and the colder phases for the eastern U.S., where those convective areas occur. Again, a summary of the last season of the MJO being more of a null phase, minimal weather impacts. And then we talked about the QBO, which is very important over the equatorial, up in the equatorial stratosphere, going from an east to a west QBO. Now, easterly QBO is a forecast this winter, which should be really interesting. All right, and then we cover Pacific Decadal Oscillation, Eastern Pacific Oscillation, the Pacific North American pattern, the PNA, positive versus negative, and then the Arctic Oscillation. Covered that. All right, I'm looking forward to part 3. I cannot wait. It's going to be exciting. Thank you so much for subscribing to the Spot On Weather YouTube channel. I've noticed the numbers of the subscriptions increasing over the last week. I've noticed the number of views have been up there as well, quite a few views. So we sincerely thank you for subscribing to our channel and just hearing us conduct this winter weather forecast and all the other videos we put on the Spot On Weather YouTube channel. All right. I wish everybody a great evening. Take care. God bless. And until video 3, until next time, as this will continue, I wish everybody a great evening. Spot On Weather, where we do accuracy through precision. Have a great one, everybody.